So when you do those equations, you find the force you're looking at is gravity at the quantum scale. At the quantum scale, space-time is highly curved.
We might just be looking at gravity wrong. It's not like a pull.
It's a flow that produces a pressure. If you want to bring it back to you, you can say my mass of all my atoms is because it's flowing with space-time. The gravitational field that I produce is the flow of space-time in my body. It's not just technology or objects outside of you. There's a flow of information going through you that's organizing you. I'm about to publish biophysics papers, equations of coherency all the way to the neurons of the brain, showing that actually we could physiologically describe the nature of consciousness as being connected to that field. And that's why I was saying, you know everything already.
Hello. I wish I was in the lab with you.
Yeah. Well, come and visit.
In France, right?
Yeah. It's pretty around here. Big mountains.
We could go skiing.
You love to ski, no?
I do love to ski now. I've taken up all kinds of things since I stopped racing. Skiing, golf, well, vacations in general.
That's a good thing.
Burning Man, which we saw each other at.
Yeah, Burning Man.
Did you have fun?
I did. What about you?
It was good. It was really good. I had a great burn. Every year I go, I feel like I miss it more.
I know. It's so good. I think it's a really good way to remind ourselves about how life could be, on Earth.
No doubt. Everyone's so friendly. Like you go there and everyone's like, hi, how are you? Oh, welcome home. The first thing you hear when you come in the gate is welcome home.
Welcome home.
Feels so good. It feels so good. Well, we can be home in this conversation because you and I, when we talk, we just go on, and you have all the answers and I have all the questions. So this is a great scenario.
No, we all have all the answers. The equations show that the universe is holographic and that all the information is present in every atomic structure, that all atomic structure is linked and entangled. And so you're made out of these atoms, you're made out of these little singularities. And so you have access to all information. And in some ways, there is entropy in the system. There's a loss of information. That's the part that you call the unconscious. It actually has a real value in the physics of the material world, meaning it's not something that's like some esoteric thing. It's actually running your body. It's like making sure everything is functioning, and it's a remarkable thing. You're an amazing genius just by the fact that you're able to organize that much material and energy into a body and be here and actually experience this world. We can definitely help each other remember, but I really am a believer that when you hear a truth, it's a truth. When you hear something fundamental, it's fundamental, it's a truth, and it awakes something in you. So that actually it's not just a linear transfer of information. It's you're receiving information from another source than the linear relationship that, when we're talking.
So you're saying there's a third point of contact? Is that what you mean by that?
That it's like we're linked to the same thing, and we're talking linearly right now, you and me.
Mm-hmm.
Although it's still kind of non-linear because we're on Zoom, so it actually
True. It's actually literally non-linear,
right?
From an energy standpoint.
Yeah, we're connected to the same thing even in the physical world, right? We're connecting to servers and satellites. You could think of as this other source as another thing you're linked in. We linearly, in our relationship, meaning in our direct relationship, we help each other remember things. But as well, we have an innate connection that allows us to get that information internally as well, so that it's like a match. It's like a resonance match. It can recognize, things that are true, that are, or at least closer to the truth.
When I was talking to Robert Gilbert, we were talking about how you sort of information arrives and how you get information, and that in another dimension or another existence where you do exist, that you get information here at times in what he called a pack thought form. So we're talking about this sort of linear, like, time it takes to get something, but in another dimension you get it as a pack thought form, adding to your argument that it's all available and it's all right there and we're all connected. Sometimes you get this sort of block of information that didn't necessarily take you seeing it, feeling it, hearing it, knowing it on your own. It just arrives, and all of a sudden you have this in a second. You get a new whole concept or idea. And he called it a pack thought form. And I was like, yes, that's exactly how it feels, right?
Yes.
That's a good language for it.
Yeah,
And
like a quanta of information.
right. And you don't have to labor over this linear sort of discussion we're having. It's as if this whole discussion would be able to be downloaded into someone's mind instantaneously in a second, the whole conversation. And that is just, like, I thought, a great way to describe what's available to us that we don't always know. So I agree with you that we all know it all, but we just can't tune into it or figure out how to get there. So, like,
no, we can.
How do we do that?
Do.
But
we do.
Right, but it's hard.
We have to get better at it. Yeah.
How? I mean, how do you do it? And how often does it happen for you? The holiday season is starting, and it's easy to fall on routine this time of year. That's why I've relied on drinking AG1 for the past 2 years. I ditched my other supplements for AG1, and I don't plan on stopping anytime soon. AG1 especially helps me when I'm traveling and need an easy way to support my health. With added benefits of probiotics, prebiotics, and adaptogens, AG1 can help combat the stress of holiday schedules while helping your digestion and supporting your energy. What I love about AG1 is that they come in individual packs. I can take them on the go, which makes it so easy for not only my work, but the holiday travels I have coming up. I've noticed since I started taking AG1 that my gut health is so much better. My stomach is flatter, less bloated, and I can eat basically whatever I want. Before I go ahead and put coffee on top of it, I go ahead and use AG1 first. So this new year, try AG1 for yourself. It's the perfect time to start a new healthy habit. And that's why I've been partnering with AG1 for so long. And AG1 is offering new subscribers a free $76 gift when you sign up. You'll get a welcome kit, a bottle of D3K2, and 5 free travel packs in your first box. So make sure you check out drinkag1.com/prettyintense to get this offer. That's drinkag1.com/prettyintense to start your new year on a healthier note.
Well, because of what I do, it happens a lot because I have to continuously be creative in exploring the physics of creation. Meaning, like, I have to continuously work on equations that to refine them, and in order to do that, I have to have inspiration to, like, visualize things and explore them and think about concepts and how does it fully relate to our reality, and so I'm constantly digging into that field of information within myself, right? People call that instinct or, gut feeling, or, they have many words for it, but really it has to do with, intuition is a really important thing in physics. And many physicists
That's controversial.
Yeah, but it's not so controversial. I mean, it was described by Einstein, it was described by Heisenberg, it was described by, Planck, it was described by some of the greatest physicists in the world. It's only controversial because it's being bred out of the educational system. So physicists today in general, don't trust their intuition very well. They believe that if they keep writing physics, actually, if they keep writing mathematics, that they will understand the universe, and that can lead them astray because actually mathematics is secondary to uh, knowing, meaning that you have to have a fundamental concept of the physics you're trying to describe, and then you use the mathematics to describe it. And if the mathematics add up, you know you've found something, good.
Yeah.
If they don't, then you keep working it, but it comes from an idea, right? The mathematics can inform you if your idea is precise or if it needs some more work, or if you thought it was like that, but it's actually a little bit more like this, right? Kind of deal. But it can't tell you what the universe is.
And we've talked about this before where there's an intuition. You see something, whether it's, look, even the Bible talks about visions of things and coming in their sleep. And this is intuition. This is the quantum talking to you.
Right. I mean,
And
not
so
to
the
be a
math is then what
cliche.
you do to prove it, essentially.
That's right. Not to be a cliche, but Einstein did say, imagination is more important than facts. The reason he said that is to make a distinction between the exploration of physics and the mathematical constructs that we built. The mathematical constructs that we built are important to back up the ideas.
Sure.
But the idea got to come from inside you. It's got to come from, or at least an exploration.
Is the math that important? I don't know. That just dawned on me.
When you get an idea that's correct, typically you recognize it, as I was saying.
Right.
And so why do you need the math? Because you're going to build technology on this idea. You're going to go out and you're going to say, okay, now I can extract energy from the structure of space-time because I figured out how it works and how gravity works. And now I can control gravity. We wrote mathematics that told us how the electromagnetic field worked over 100 years ago, Maxwell's equations, and then experiments were done with Faraday and so on, and we developed our whole civilization based on that discovery about the mathematics of electromagnetic fields. And all of our device work with this mathematics, and we use these mathematics to engineer devices. When we find more deep levels of concepts of the structure of creation, like understanding the forces better, understanding the material world better, all this leads, theoretically, leads to technological developments that can transform your civilization, like most fundamentally, at the most profound level. And every time, so all of a sudden, let's say you figure out how gravity works really well. Not only did you figure it out, but you find that it's related to the electromagnetic fields, which we can control, right? Because we have those equations. Okay?
Yeah.
Now you have a way to interact with these gravitational fields.
Right.
Now you have the key into the door to gravity control, space exploration like never before, transports of goods around the planet without roads, and, it changes everything. Just as much as, the Wright brothers' discovery changed everything in terms of transportation around the world. Hey, you.
They're like, what about us? I'm like, soon. We have big questions to ask.
They They want to
Hmm.
learn about the universe.
Oh, maybe they already know. Do you think dogs are
Well, they
smarter than
probably
people?
already know, yes.
They're like, we
Sorry.
have it figured out. Eat and lay in the sun. If there's one thing that I feel like I've learned from my medicine journeys and deeper sort of connection to source or to God or to a higher dimension, it's that it's really about just experiencing it. Like this reality is about just experiencing it. And it's not a lot more than that. And that's kind of frustrating because I feel like as human beings, we're such meaning making machines and that we have to sort of like do something and that there's something to do or accomplish. And while I think that there are some
I'm
legitimate
very
reasons
guilty of
why,
that.
yeah,
Yeah.
oh, I'm so guilty of that. And that's probably why we're like having a conversation and sharing it with people. But at a core, we're like really just meant to experience things. So we'll do that later today. But right now, we're going to like explore things and talk about things. I know that one of the things you had mentioned earlier this year is you were working on some papers on the unified field theory. And you had mentioned that you have some presentations. I don't know if that's part of it. The origin of mass and the nature of gravity. I mean, my favorite movie is Interstellar. The whole concept of that movie has to do with gravity. So, well, I was just going to mention that you had talked about gravity a long time ago and you had talked about a black hole, but the black hole is that you had said we are each individually a black hole.
The atoms you're made of are like that paper I'm presenting is just supporting evidence that there is a black hole at the center of every proton in the nuclei of the atom. And that sounds really outrageous, but actually it's a it's a theory that Einstein worked on and with Rosen. And it produced some of the most significant mathematics that describes wormholes
Oh, wow.
between particles, that describes that network that I was talking about earlier. You know, these wormholes have now been like this, a lot of supporting evidence that these wormholes between particles
Mm-hmm.
is what produce entanglement in quantum mechanics.
Oh, one of my favorite topics.
So wormholes have to do with gravity, right? They're solutions to Einstein field equations. And entanglement has to do with quantum mechanics, which demonstrate that atoms can be in superposition state. That is, that they are connected, you know, at infinity, meaning
Yep.
like you can have them infinitely far from each other and they are in communication. The two put together is the unification of physics. It's in the mainstream described as ER equals EPR, and I'm not going to go into too many details there, but ER stands for Einstein-Rosen, and
Mm-hmm.
that's the Einstein-Rosen bridges, which is the wormholes. And the other side is Einstein-Podolsky Rosen, and that's the entanglement. The work I wrote put the two together, but formally. That is, ER equals EPR is known informally. It's not a complete theory. It's from the top physicists in this world, though. It's like very well-known physicists. But it's more of an idea than a full theory. This finishes the job.
Okay.
Yeah.
That's so
And,
exciting.
you know, people don't realize that we don't necessarily know the source of mass. The source of mass is not something we know in physics. It's not fully described on the quantum side, meaning
When you say source of mass, are you saying like where it came from?
like what is the mechanism that
Yeah.
produced mass in the universe?
Yeah.
We have this concept of mass. It's a word we use. We know it's equivalent to energy, right? Because of E equals mc squared, because
Yeah.
of Einstein, right? But we don't know how it makes the mass of matter that we see. We have
Right.
concepts, but they're not complete. This completes the picture. It's in pre-published state, so I should say that. Like, so it's undergoing peer review in very good journals. So it's almost been a year now that it's in pre-published state. There's been 60,000 downloads. So we're clear that's very rare for a physics paper to have that many downloads. We've not received any return that there is mathematical error. So actually, we receive return from very well rated physicists in this particular field of 0 point energy. I'd like to give you a little course on quantum mechanics.
I would love that. Go for it.
Quantum theory really started with Max Planck. What he was commissioned to do was to make a better light bulb. So he was trying to make a better light bulb. And to do that, he had to solve equations that are thermodynamic equations. Like, the little filament in the light bulb was heating up and outputting photons, right? So, but he didn't have photons at the time. It was just the electromagnetic field, right? His field was coming off that was emitting light, right? And he was trying to figure out the thermodynamics of the filament so he could make better ones so that they don't burn out. And he knew already that there was a problem in the thermodynamic physics of the time, that it predicted that the little filament was going to emit all kinds of frequencies, right, at different temperatures. So hotter it got, more higher the frequency. And then it would get into the ultraviolet, and the equation would say that it would emit infinite amount of ultraviolet. It was called the ultraviolet catastrophe. And in the laboratory, they weren't measuring an infinite amount of ultraviolet, right? So they knew there was something wrong with the theory. Planck got on it and said, okay, what do I have to do to the equation so that it works, right? To match the experiment. He had to add this little constant value that's called h bar. Omega beside it is like the thing has a pulsation. It's the pulsation. It's describing It's describing an oscillator that's producing heat, that's emitting electromagnetic fields.
Wait, we're looking at the equation on the bottom. The h bar, is that the HW?
Yeah, exactly. The omega is the, W, and h bar is the Planck's constant. It was called that at this point. And so Planck didn't really like his equation because he felt like he was putting a fudge factor in there. And it predicted something weird, is that the electromagnetic field that was being emitted in packets, in quantas, in quantities.
Oh,
and
like clumps?
So in clumps, yes, exactly, clumps of information.
Mm-hmm.
He thought it was weird, but it gave the correct answer. It was adopted. The problem is that typically when an oscillator is taught in schools today, when you're learning quantum mechanics, the first thing they teach you is about an oscillator, and they typically give you a spring on a weight that's oscillating back and forth.
Okay.
As a visual. That's not really what the universe is doing. The universe is not making a spring and, oscillating it.
So
there's
that's like
nobody
a 2D.
Up there going like
it's
this.
It's showing you 2D.
Yes, 1D.
1D.
Yeah. When we know that, like, it's mathematically, equivalent to a sphere spinning, right? With the period, right? But it gives the wrong visual to all of the students. So it's really kind of a problem, because it's really important to keep the mechanics of what you're describing in your head correct. If you have a model that is mathematically equivalent but mechanically incorrect, then you can be led astray. So I'll give you an example. Like when we had a geocentric solar system, right? We could predict the position of planets with 99.98% accuracy. But we had the Earth in the middle, and the solar system looked like a bad hair day. to be able to like do these prediction, like their path through space had all kinds of spin and geometry and all this, which is all true if you're observing from the Earth, but the center of the solar system is the sun, right? So it's that from that frame of perspective, then the solar system is this very orderly thing with orbitals, and then you can, be much more precise. So it's really important to get the right visuals, right?
Yeah.
You can have the mathematics tells you both are correct, but if you don't have the right mechanics, then that's an issue.
Sure. Well, that helps the intuition. It helps the visualization. It helps the logic to try and connect the dots on things.
Exactly. So now you're thinking about a sphere that's spinning, a little oscillator, a little atom, a little proton, the nuclei of an atom, or, a particle that's oscillating. And this is what Einstein thought of. He said, those could be like little packets of energy that is knocking the electrons off in the photoelectric effect. And he wrote a paper on that and called them photons. And that's how we got photons, particles of light. Einstein won the Nobel Prize for this. A point we make at the beginning of the paper, because we're kind of recapping the history. We wrote a big paper because it's part one of a series of 3. And we actually put a lot of the history at the beginning, which would not be in a final published paper, because you assume the physicists in general know that history. But we're making, even in the published paper, we're making very specific points about how in history we have to remember how things happen. And so when you look at this H bar equation, well, it's describing an orbital, something that's spinning. The H is considered a quanta of energy that's resulting from an angular momentum, a little spin. You can imagine little spinner thingies, the oscillators, that are oscillating and like spinning. You can find that this little energy can be quantified in terms of energy, right? So E equals H bar omega is like the energy of the little system. But that has not been put together with E equals mc square, which is telling you about the energy of matter.
So are they meant to correlate? Like this is what you're saying about an equation then connects to another equation. And then, so do they connect?
Yeah, exactly. Think in terms of frequency of oscillation producing the energy. You can think in terms of mass, with velocity of light, right? The energy of the velocity of light put together, giving the energy of the system. The thing, though, is that the part in mass, in E equals mc squared, that's mass, is undefined. What is mass? What do you mean by mass?
Yeah.
And what do you mean by the speed of light? Meaning we know the speed of light is the speed of light because we measure it. But why is it the speed? Yeah. I mean, from your own experience very well that when you press on the gas and put more energy in the system, it goes faster, right?
Yeah. You like speed too. You know it. You know what it's all about.
Yes, I do. I like speed. I know. Gets me in trouble. Yes, this is the same thing. So when you put energy in a system, right, there's frequency change, right, and more packets involved. You see? And so you can start to see a little bit the relationship, but then there's something really not good that happened. Planck was trying to solve this equation. Actually, it was a really good thing. They just didn't know what to do with it. And so when he explored his equation a little bit more, he published this later on, he, was trying to figure out the internal energy of the oscillator.
Okay.
Right? The energy of the whole thing, like the internal energy of the oscillator. Then, using the same equation, what he found is that there was a problem. So he had replaced one infinity, which was the, ultraviolet catastrophe, with another. When he calculated that term for the internal energy of the oscillator, he had an extra term that's the little inside the circle, the 1/2 h bar omega. That was an extra to his equation. That meant, remember, at certain Kelvin, it's certain amount of photons, frequency of energy that's being emitted. He found that part meant that, like, if you went to 0 Kelvin, right? If you went to like absolute zero,
Does that mean
right?
no motion? Does that mean no movement, no energy created?
That's exactly what it should say, that there's no movement, there is no motion, there's nothing, there's no thermal agitation. The thing should be dead. The oscillator is dead like a doorknob. It's totally frozen. It's like worse than Alaska, it's like really bad. Well, the equation says that there's actually an infinite amount of energy there.
Oh, shit. What does that mean?
That's why it's called 0-point energy. And that's why he called it that way. At 0 Kelvin, there's still a lot of energy, infinite amount, in fact, according to the equation. Now, the equation is the basis of quantum mechanics, and we know it's correct, and we've measured these things left and right in all directions, very, very truly. And we have precisions, that range in the 10 to the minus 10, that is 10 number after the period, and so on. So we know it's correct. We can't get rid of this 0-point energy. That is, although it was ignored, you actually mathematically, rigorously cannot get rid of it. You can't say it's not there. It's
There's
a
no
problem.
such thing. There's no such thing as nothing. There's no such thing as nothing. There's always something.
There's always oscillation. And actually, there's so much oscillation as you get into the finer and finer, nearly, of the frequencies. You have infinite amount of information. You have infinite amount of energy.
You're getting closer to the source, closer to the original energy.
That's right. So it's like he had found God.
Yeah.
But he didn't know. You would think that right away they would think, oh my God, we found this energy source of everything, right? It's called the ground state of the equation, meaning it's supposed to, like, everything that emerged from that is like the residual of that energy. And the reason why it's called the ground state is because what they did is they said, okay, but we're going to say that all the frequencies cancel out to 0.
Do you agree with that?
Well, it's a big problem, because now you have an oscillator that doesn't have a source.
That can't be.
It violates laws of conservation of energy, if you'd like. I mean, I'm saying that loosely. Proper technical term, it makes the equations of quantum mechanics commutative when they should be non-commutative. And I'm going to explain that in a minute. It sounds like big words, but it's really just straightforward. Okay, so basically, the equations is describing that the field at the ground state is fluctuating and it's canceling each other out. And the fluctuations, they're described as operators that are appearing and disappearing, like particles that are like popping in and out of this quantum field of this ground state.
But the ground state is a field of infinite energy, right? But it's not telling you what kind of energy but just that there's potential energy.
That's right. It's just saying that there's a potential energy, like that there's infinite amount of frequencies, infinite amount of modes of oscillation in this field, in this soup, right?
Okay.
Dirac called it it was called the Dirac sea, but he called it a sea of energy, right? It's like particles popping in and out. And they assume that you could just set it to zero to make it the ground state by just assuming that all frequency cancels out.
That's a stretch.
What happens is that if you do that, you set the field to zero, you end up with an oscillator that doesn't have a source of energy. So if you go back to the spring, when the oscillator is going up and down, is because somebody is doing this with the spring, right? You stop doing that, then the spring stops.
Right, because it's a stop. It's actually an up, stop, down, stop, up. Like that has to be manual.
That's right. And so if you remove that, if you remove the hand that's going up and down, if you remove the energy, the source energy of the oscillator, it will stop oscillating.
Yeah.
It's called self-interaction. And then the whole thing is going to collapse, right? The electron would lose all its energy and collapse on the proton, and the whole thing goes sideways. When you look at the ground state, right? Basically what we kept is only what's being emitted, the little, like we ignored the infinite energy source of the oscillator.
Okay.
Right? And it is because it has an infinite or near infinite energy source that protons are completely stable. The nuclei of atoms don't do anything. They don't go anywhere. They just keep on oscillating, and they're in like some kind of like perfect state of equilibrium. They don't decay. They don't do anything. Since the beginning of the universe that as far as we can see, the protons don't do anything. The nuclei of the atom can decay into protons, neutrons, and stuff like that. But the proton themselves and neutron, as soon as it's ejected from a nuclei, becomes a proton. So in general, I can just say proton, and the protons just don't go anywhere. And so because they are fed by an infinite source of energy, they're fed by that 0 point energy, and that's been missed because they set the field to zero. They set it to no energy. So now you don't have a source of energy for your atom. You don't have a source of gravity for your atom. Now you gotta write. So this happens in physics all the time. I'm sorry, I get excited about this stuff. It happens in physics all the time, is that we extrapolate to a conceptual notion of physics and remove the mechanical requirements for that conceptual notion, especially in quantum mechanics, that's common. And so now we have an oscillator that doesn't have a source of energy.
According to them, well, according to their math, saying that there's nothing. They're saying everything cancels out at zero. But it's not, it's infinite. And it's also not moving mechanically in the way that they're describing it.
Right. That's correct. Yeah, exactly. But as well, the math might is correct to describe the oscillator. It's not connected to reality anymore because it doesn't have a source of energy. It's just hanging in mid-space. So you're getting the right math to describe the oscillation and all this stuff. And you can say, wow, it works well and it's precise and all this stuff. But when you look like what is mass, what is the gravitational field of this thing and how does it work? How does gravity work at that level? Now you're missing big pieces because you don't have a source of energy.
Okay. So where is it? How do we make this make sense?
What in this slide, I know it looks a little difficult, but basically in the big circle there, that's the part where it cannot equals to zero. When you put the 0 point back, right, you find that the equations are non-commutative, which is what you want, right? In quantum mechanics, it has to be that way. We know that. And so they actually ignore the fact that, like, in general, you cannot just eliminate 0 point. It has to be in there. And so when you put it in there, then they become non-commutative. That means that it just means that, the little oscillator, it's emitting photons. Remember? That's
Yep.
how he got those equations,
Yep.
right? It's thermodynamic.
Yep.
And so it's absorbing photon as well, right? It's called a black body. That's
Okay.
how the equation is written. So it's like how if you have like black jeans, they heat up a lot more than if you have white ones,
Right.
right? And so it's absorbing photons and getting hot, right? You can think of it as this little oscillator is absorbing photon and emitting photon, right?
Okay.
And so that it cannot be that total is 0 because you have mechanical dampening, that's in the system. It has to have the energy to make it continue to oscillate.
Right.
Just like your race car needs to continue to have some kind of motor producing energy for the wheels to keep spinning, right?
Right.
Which are oscillator, right? And so it's the same thing. So when you put it back, then the equations become correct. This is what made Einstein say these things, and Wheeler. In here you can see that, like, Einstein tells us physical objects are not in space, but these objects are spatially extended, right? Meaning it's the 0 point energy or this fundamental energy that's in the space extending itself. Now, we think linearly when we think extending, but think like spinners. It's making vortices, okay, that clump together, and it's like the space is becoming a solid, right? Like a phase transition, right? Like it's a more solid, it's a more organized part of the 0 point energy. Right? And that's not Einstein. That's what I write in this paper, right? So that there's parts that are organized. There's parts like chaotic that are canceling out. And you call that space. But where it doesn't all cancel out, it's matter. That objects are spatially extended in this way, the concept empty space loses its meaning, right? So said, like, there's no such thing, right? This is one of the greatest thinker, and he didn't say this based on only intuition. He said this because of 0 point energy. But people think, like, I talk about this, and they don't realize what I'm talking about is their own existence as well, because you're made out of matter. So how many times do you think of yourself as an extension of space?
Yeah. I mean, only when Joe Dispenza makes you do it in a meditation.
It's a really good thing to realize that space is not like nothing, but actually it's something.
So what then creates the levels of density of matter?
But basically, so we wrote equations that are very commonly used, actually, in both quantum mechanics and classical equations, and that electromagnetic equations that basically say, okay, well, this fluctuation, this electromagnetic fluctuation of the 0 point, how many of the wave actually cancel out if you integrate across all modes, if you take all frequencies to infinity, right, and you put them together and say, how many actually cancel out? Is there if I confine, right, a region. So if I confine a region, I say, this is the vortex I'm looking at, right? And I say, okay, so then there can't be any wavelengths longer than this one. And then I can go infinitely small, right? All the way down to the Planck scale, which is trillions and trillions and trillions of times smaller than the atom, which is a fundamental scale in physics. If I do those things, then I can calculate the energy of all the waves that cancels out and all the waves that don't, right? And so look at this equation on this slide. Basically, the green little, arrow is an electromagnetic wave going that way. And the blue arrow is an electromagnetic wave going the other way. And the red is the resulting energy of the system.
Is it from those waves interfering?
Yeah, exactly. How there's waves that are going to build energy and there's waves that are going to cancel energy, right? And the phase between the waves is going to decide how much energy is created and how much energy is canceled. The phase between the two waves, right? As they meet.
Mm-hmm.
And so you can write.
So what's the graph at the bottom right? That's the interference result, essentially?
Yeah, exactly. So, when the waves, the green and the blue are exactly in phase, you have almost infinite amount of energy produced. Infinite amount of energy, right? So if they're exactly in phase, right? So the red should go to infinity. I cut it before infinity because I wanted to be able to show what it looks like. But it basically, right, it should, when it's in phase, it goes to infinity. And if it's completely out of phase, it goes to zero, right? There's no energy because, the waves are completely canceling each other out.
You know what I look at when I see this? Because I look at things in a correlated fractal parallel way. This looks like a relationship. When you're in phase, your potential is infinite. When you don't get along, it's nothing.
It's not, yeah, it's nothing, or it's actually really bad. You're losing energy.
Yeah, exactly.
You can use these equations, and I'd like to say that I'm suspecting that the universe is never in 100% phase or 100% out of phase. There's always a phase relationship. There's always a distance, and between the two crests of the waves, because that's how matter is made. It's that distance. So I'm gonna show you, and that distance is tau. This is what we're showing in that equation. That the tau you see in the equation. So you see, remember, one side of the equation is the wave that's going right, and the other side is the wave that's going left, right? Mm-hmm. And they're added together to produce the total energy. And in these terms, you have to put the phase that you're trying to calculate the energy for. See, if tau is at zero, then you have infinite amount of energy. You see?
Yeah, I see.
You see. So basically, now you can apply that, and you say, okay, well, is it correct? Is it giving the right answer? Right? If I put the distance being the Planck length, the Planck distance, okay, like the smallest oscillation I was talking about earlier, and between the two crests of the wave, do I get the right energy for that scale? And I do. You get the right answer. You get the right mass.
And are you calculating based on some portion of phase, or is that top graph in perfect phase? It doesn't look like perfect phase.
No, exactly. Right. Between the two crests of the waves, there's the Planck length.
Okay. So this is the the previous slide was perfectly in phase and completely out of phase. So this is all of the in between, which is you think our reality.
That's right.
Yeah.
That's right.
And it measures out correctly.
And it gives the right answers. So then you say, okay, it's good for the Planck length. It gives the Planck density, which is a lot of energy because the Planck length is a very, very small phase between the two. So that most of the energy is kept. It's almost infinite amount of energy. You lose a little bit, which is the Planck density, and that's the mass of the Planck. So
Okay.
then you put the proton in there. Now you've changed scales by billions and trillions of scales, right? You've changed huge amount. Like the Planck is so teeny, relative to the proton. So that if I grew a Planck to a grain of sand, the proton would be from here to Alpha Centauri, like 40 trillion kilometers. So, it's like, it's a huge change in scale. Well, then I put for the tau, for the phase, I put the proton. And if you do that, then boom, you get the right value for all of its mass.
In the phase that it's in, you get the math that proves correctly for the amount of energy of that phase that you're calculating.
That's right, which is exactly the mass of the proton we measure.
Wow. Is it possible to get the math to prove what the infinite potential is? Is there actually an infinite is not a number, right?
Well, this proves that basically the energy of creation, like mass is the energy of all matter in the universe, is coming out of this field of energy, this fundamental field. So which includes all the atoms that you're made of.
Wow.
This is
Well,
where
there's
it
not
gets
many
really.
to me because I'm tiny.
Yes, I know.
Maybe some
I
are more, and maybe I have a little bit more phase than some people, though. Maybe they're a little bit more in phase.
You definitely have more energy than a lot of people. So if we put your size, in the phase, in the tau value.
I mean, is that like from a spiritual perspective or an energetic perspective? Is that what gives people perhaps their sort of aura or the field that they create? Is how much maybe more in phase or closer to aligned that you are, and that create, because there are some people that just they emit a lot of energy. They fill the space of a house in their energy, and then there's some people that you'll never notice.
Right. Well,
I wonder.
So the equation you just saw that give the correct masses, right? They are equations that are described in textbooks as equation that describe the coherent state of a field.
Okay.
So it's a state of coherency. How much coherent behaviors are occurring in that space that produce energy, right? More this is coherent, more it's in phase, more energy, right? Less coherent, more out of phase, more chaotic, less energy, and more, chaotic behavior, so less coherent.
So can you go backwards from the energy emitted and get the phase graph essentially? I'm lacking the big words that are you have,
That's really
but can
good.
you reverse can you, instead of looking at the phase to prove the energy, can you do an analysis on the energy and get the phase?
Okay, there's a few things. I know you're not talking in terms of engineering, but you're a good engineer. You've made cars, no?
No,
Yeah.
someone else did that.
Oh, yeah. Well, you understand how they work.
Yeah.
Yeah. So, think of it's like you figured out that gasoline can bang, right? And now you're going to make the device that's going to use that bang. You call it a motor.
Okay, yeah. And you have to test those out. I mean, you don't just build the perfect motor off the bat. You go, this is our guess, and then that one blew up. Okay, let's reduce this, let's increase that. And you find sort of the balance. So essentially it's sort of like some testing that goes just like you would test out these equations to figure it out. You're kind of continuing to back things into each other.
Exactly. And, and And every time you test out and it blows up, you go back to the blackboard and you go, okay, let me run the equations precisely, whatever, like, and then you get a better idea of what mechanically you missed. And then eventually you tune it in and then it's good, right?
So what can we do with this theory proving true and the discovery that you've made? What do you hope to do with it? What can humanity do with it?
Okay, well, remember, those are electromagnetic fields, right? That are interacting these waves, right? It's a field, electromagnetic field, right? Remember the equations of Max Planck. So you can see, because we can control electromagnetic fields, we know how to control them. And if we understand well how mass or energy is created, what do we have to do to this field of energy for it to like create energy, to emit energy like it does in atomic structures? Well, instead of using the atoms to make the energy, we can tap directly into it.
So if you put something more in phase, you create more energy. And anytime you get more energy, you can do more things. I mean, even, the things that I'm sort of going into now, when we look at like energy, free energy, the Tesla sort of story about creating it versus what we try and use now. But moving into the AI world and the technology and the data needed, like the amount of energy needed to power that is apparently immensely higher than what we're doing right now. So is
The
that how
amount of
you...
energy needed to run our world is significant and needs to be a source of energy that's clean and
Yes,
that's
clean and
available
sustainable.
and sustainable and available everywhere you are,
Right.
not, connected to some cables,
Right. Or some natural resource that will run out someday, perhaps.
exactly. So this is an opportunity, because if you understand, remember, E equals mc square. If you understand, oh, this is the source of mass, this is the source of energy, right? Then you go, okay, now I can see a path, an engineering path to getting to that energy, to getting to that source. You see? But if you don't know, then it's not clear.
Right. So is this where, because like we also share a deep love of ancient civilizations, and is this where maybe in ancient times they used frequency to give them the power, the strength, the ability to move megalithic stones, to build what they did, to carve what they did? Like, is this maybe where, like, some of the technology that they maybe had to be able to do those things because they were able to create more energy?
Sure. What I think is that in this universe, many civilizations have figured this out. And when you look at the history of humanity, it's just not a nice, pretty, smooth, linear evolution from the monkey to us. It just isn't. There's all sorts of anomalies on our planet, as you know. And
Like,
as
like
we
alien adjusted DNA. I'll say it so you don't have to. Like leaps in our ability to be able to do things like speak and read and write and things like that?
there's these things, and then as well there is, you know, physical evidence all around our planet that there's been some kind of civilization prior to us that left monuments and things that are very enigmatic, that are not easily explained. And I'm talking in terms of pure physics. It's
Yeah.
like, no, like you cannot move 1,000 ton
On
of
stone.
material across the desert, over mountains. Like, I don't care how many slaves you got.
Yeah.
It doesn't happen. Like, we can't do that today. Like, forget.
Why haven't they actually done that? They should literally try and get logs, ropes, and people and see what they can actually do. I know they've done it with machinery to try and see, oh, we can't pick it up, our forklift tips over. but I'd be so curious to see what would happen when they tried to roll 100-ton stone over tree logs with ropes and then
in the
up,
sand.
uphill, yeah, in the sand, and then uphill up a slope to build a pyramid. Like, seriously, it's
Yeah,
insulting our intelligence.
or yes, or over a mountain range, like in Peru.
It seems it's so ridiculous to think that these stones would be put on ships or pulled on logs or, pulled up into position on a pyramid. It's just ludicrous. So based on the math and the equations and the discoveries that you've made, is this the correlation? Is this something?
I certainly could imagine that, like, a civilization after discovering, if we go further in the presentation, we can see the rest, but I can just talk about it as well. But you can imagine that, because this discovery I just talked about the mass of proton, involves gravity, meaning that, like, when you continue with the equation, I would show you in the presentation, when you continue in the equation, you realize that actually gravity is just the pressure of this field on the surface of the thing that the little proton.
The best sort of visual example I've been given, right, is sort of like it's like essentially a soft fabric surface, and you put a different weight of a ball on it. It sort of shows like how much it sinks, and that's an analogy for the gravity. But is that even a good visual example of what's really going on? Because that looks like stuff bends into it, but maybe that's not even what you're talking about.
Well, it's close. That's the typical example. Usually they talk as well about trampolines, and
right.
If you put a big weight on it, then it curves the trampoline and the other ball would, like, roll towards it. That's Einstein field equation. We were just doing quantum mechanics, right? But Einstein field equation doesn't agree with quantum mechanics, because Einstein field equation in this formalism is written as a smooth surface that's curving like that, that's producing gravity. And why is it the wrong visual? Because let me try to make this more clear. It gets technical, so I'm just gonna try to say it concisely. Einstein field equations are fluid dynamic equation at their foundation. And it's better to visualize when you pull the plug in your bath and it makes a vortex, and you have a rubber ducky. I'm sure you have a rubber ducky.
I had a rubber ducky.
And you have, the rubber ducky going around the drain because it's getting caught in the vortex. And that is much more accurate to describe gravity. And what Einstein described is, if you look at the water, it's curving into the drain. So he described that curve into the drain.
Is that because something's always spinning? So instead of looking at it as just being one curve, it's actually a lot of things spinning and creating the energy or having the motion. Like, again, it's kind of the oscillator. It's not just this, it's actually a whole bunch of this.
You have such a great mind. You have such a great mind. You're so bright.
Yeah, but I do this and move my fingers around and say, and then
yes,
and you
do it with the hands. It's okay. Physics with the hands is good too. That's how the ideas come. But good visualization. But so that's the right idea. So, like you said, it's made out of a bunch of little things. So viewed from far, the water looks smooth. But if you look at the quantum level, it's made of particles. So what's really happening? Is it really the curvature, or is it just that all the little particles are spinning together in co-moving frames? You see, they're all spinning together. And in that region of your bath, there's more coherent behavior of the particles because they're all spinning together. than the ones over there that like are oscillating all independently and making chaos and canceling out.
So it's not that the energy is necessarily different, it's that it's organized versus disorganized.
That's right.
That's why there's no such thing as nothing. There's no empty space.
That's
it's
right.
Just
And curvature is actually a quantum effect, meaning you have to look at the structure of space-time, what it's doing at the quantum scale. Like you have to look at the little parts, how coherent they are. And that's the equation I just showed you, right? That's how much coherency is there in that region of space.
So how do you create coherence? That's where I was talking about the energy and frequency. Like,
yeah, well,
when you look at
just a minute. Okay, just a minute. I got to finish this. Okay. So now you have the water is flowing. It's creating there's a pressure change in the drain, right? There's air coming out, water going in. There's a change in pressure, right? When you calculate the change in pressure in those equations, right? We got the mass. Now we calculate how much pressure, right, is different between the inside and the outside.
Right.
We get exactly the value we measure as the color force. That is the fundamental force of the nuclei of the atom that's holding the nuclei together. Without that force, there would be no atoms. Right?
And does that force change depending on the amount of the equation of sort of like, in that example, the vacuum effect of it?
That's what I mean.
Changes?
You're so smart. That's exactly it. It does change. It changes depending on how much small you look. Meaning, remember when you put the Planck length, then it's really, really high energy. But when you look at more global, like at the proton scale, then there's less energy. It drops in energy. And so there's only one force, right? Meaning so when you do those equations, you find very rapidly that actually the force you're looking at is gravity at the quantum scale. You see? Because it's literally that at the quantum scale, space-time is highly curved, right? There's a lot of energy.
Oh, we might just be looking at gravity visually wrong. It's not like a pull. It's an energy organization.
It's a flow.
It's a flow.
That produces a pressure.
What do you do with that? That's how you control it.
Yeah, exactly. So then you can make device that controls it. But if you want to bring it back to you, you can say, okay, my mass of all my atoms is because it's like flowing with space-time, right? Like the gravitational field that I produce is the flow of space-time in my body. It's not just technology or objects outside of you, but there's a flow of information going through you that's organizing you, right?
I feel like if when you're in coherence or alignment with yourself and doing the things that are true to you and authentic, and you're speaking it and you're doing it, like I've experienced this in its own unique way very recently, like everything goes faster. The way that the universe delivers more of that and bigger things, it's like, it's wild how quick things go when you get into alignment. So maybe that coherence is actually sort of getting into that higher potential energy that I know, like, I think there was also another equation that had to do with kinetic energy, but potential and kinetic. But yeah, then you can go use it. You do it.
Yeah. And I'm about to publish biophysics papers that actually scales like the same information, like the same equations of coherency all the way to the neurons of the brain, going through, microtubules and tubulant and, carbon atoms, like all the way up from the Planck scale to the neurons of the brain, showing that actually what we could physiologically describe the nature of consciousness as being connected to that field.
I was just going to say, is this actually the source of consciousness, that connected, that sort of ground zero point where everything cancels out, but there's actually all potential? That's consciousness.
Right. And that's why I was saying, you know everything already.
This was the most miraculous hour and 20 minutes of starting somewhere and going all the way around and coming back to exactly what we started talking about.
It's really profound when applied to your understanding of reality, but not just outside yourself, your understanding of reality inside yourself, like what you call consciousness, and how it interacts with the field, and what you are doing when you actually, putting an intent in the field, or when you're, like there's all kinds of like philosophical and spiritual, like all of a sudden interpretation that are very profound, that includes as well, like what happens when you die. And, like all these things all of a sudden may have a way to be literally formally described mathematically, because you have the source of energy that's making shit happen. Sorry for the word, but like,
oh, that's so good. It's so true.
It's like, and you can think of your body as literally the coherency of the field in that region of space.
Sure. So I mean, I just even think about I'm going to be like on a high after this conversation. I'm going to have so much energy, right? And then there's other things that I do that I don't want to do that are draining. It could literally be the light in the environment, or it could be what it is that I'm actually doing. But some things just zap your energy. And I wonder how much if that's a direct correlation to the math you've discovered and the way that you're describing it, and the fact that nothing is separate.
That's right.
I'm not separate from you, from the universe, all of it. And that we individually, while this is great to learn how to build new equipment to give us more power or help us get off planet or levitate things or whatever that may be, but what beauty and being able to create coherence within ourselves, to be able to create more energy for ourselves to do more things. And that, I think, I love the collapsing of all things into one idea, because I think that that's the way it is personally.
Yeah, no, I agree. In terms of consciousness, it has a really deep impact on your knowledge of yourself and the universe and your relationship to it. So the reason I was mentioning that is because it doesn't only apply to gravitational fields, or even like I could see technology that eventually creates matter out of the field. Like basically you can start creating coherency in a region of space so that it starts outpouring, protons. We already do it in the standard physics by oscillating two plates very, very quickly, very close together at microns apart. It's called the dynamical Casimir effect. And then photons pop out of the 0-point energy. The photons are coming out. It's literally electromagnetic fields radiating from the system. From there to making matter is something that I could visualize, that can happen if you understand how to create the coherency and in the electromagnetic field of the 0-point energy. And I guarantee you, there's a whole lot better than oscillating two plates. Oscillating two plates is just to prove that the principle is there.
Works.
But, there's just better way to create a gradient than 0-point energy. Right.
I know that takes money. It takes time as you sit in your lab. I've gotten more into politics, so I don't know if you think Elon could help. Maybe someday I'll meet him and, you guys
I would love that.
Change the world.
Yeah, I would love that. It's been very difficult in history to get this type of research funded for various reason. This, what I'm talking about, was never given in such details in physics. Okay. But many people, including Tesla, had these concepts already, that there was a fundamental field. He called it the ether. I mean, that came from James Clerk Maxwell when he wrote the Maxwell's equations. There was always this field of energy present in physics. It's just a changed name.
Yeah.
And it was canceled out, as you saw in quantum mechanics. So, which is something that Einstein regretted later. He clearly enunciated that general relativity was invalid without an ether, without some field that's curving. That space-time is not just a conceptual notion, it's actually something that's real. This has been a long journey for many inventors out there. It just needs to be done rigorously with good physics, and then it can be done. However, it has to be funded. It has to be helped along. And that's extremely rare because the funders have to be visionaries. They have to understand that they're not going to be able to turn around and get the mainstream to tell them, oh yeah, that's really good, go for it. It's just not going to happen because the mainstream is on a completely other vector, trying to understand where mass comes from and building huge accelerators like the one down the road from me, to test those theories, but not getting to the source of things. And so, it would be nice if a little bit of that funding came my way, or at least the way of this type of investigation.
Well, let's get the
Because
word out there and do everything we can for you to get that funding. You're so brilliant. And you're a great educator because I'm going to tell you, as you know, I have a GED. Math was never my thing, but you just helped me visually be able to get a pathway to actually have a conversation with you about it. So you're amazing.
Yeah, you understand quantum mechanics. I mean, the foundation of quantum mechanics now. Very good. Yeah. Thank you. And I just want to say, it's really important for people to know as well that it's not because you can, describe it in terms of consciousness or evolution or transformation or, coherent behaviors and all this, that it doesn't have rigor. It can have rigor at the same time, and that's where it's really powerful because then you understand the mechanics. So like, for instance, tonight when you go to bed, you can like close your eyes and, kind of visualize and feel the pressure gradient going through the atomic structure of your body and like spinning everything into coherency and, spinning your existence together, which is something that in standard physics is not well understood. Like, how is it that like chaotic universe would produce coherent behaviors like microbes or biological entities like a human, which is like 100 trillion cells or 50 to 100 trillion cells, and that each one are made of 100 trillion atoms. This is an incredibly complex thing you're made of. And it turns out it's like all little vortices of this fundamental field expressing itself in a region of space, like an extension of space. And so I personally get a lot out of trying to feel the space around me, like feel it, not just. And then when I start to feel it, like for instance, if I go in nature, for me, if I go in nature, this is why I like skiing, climbing, mountaineering, all this stuff, like, is because when I'm there, it's almost palpable in nature, the feel, the interaction between things, like you look at all the relationships that are happening in the dirt and in the trees and in the bugs and all this like incredible and the field that connects all that. And then when I get that sense, I get usually like chills, I get like really, and then I feel like a connection, a belonging to the rest of the universe, that then I can go inside and then start to visualize or feel the energy of the space at that level, because it's not just outside of me. The atoms I'm made of are 99.9999999% space. That's a lot of space, and we just learned that space is not empty. It's full of energy, right? It's actually feeding those things you're calling atoms, right? Which are basically hardened space, like space in a certain state that it feels solid, right?
That's right.
And so then you start to get the feel of your existence being something more extended than just the material existence. That like the information you are is part of a field that extends, towards infinity. And deeper you go inside, farther, more connected you feel with this thing.
Oh, yeah. That's right.
Yeah. And so that makes sense. And
Yeah.
it just happens that all the masters that have walked the earth have been trying to tell people, like, check inside for a while. Kind of a nice place.
Don't make too much sense, Nassim. People don't always like that much common sense, okay? They don't, doing the work yourself is always so much harder. But it always boils down to it's an inside job. Real change is an inside job, and it's also a real education too. Yeah, I love the way you think. Thank you so much. You're amazing.
Oh, it's my pleasure.
Enjoy your sleep. I know that this
Yes.
stuff gives you energy, but it is late in France, so
Right.
thank you.
I appreciate, and I hope to continue the adventure in like the papers we're about to release as well. More explicit information, and some of this explicit information, I think you will be really happy to hear about. Like to actually put some nice meat and on the bones of what I just showed you.
When you're ready to share that, let me know.
Okay. Absolutely.
Thanks everybody for listening to the Pretty Intense podcast today. I hope you enjoyed it. If you like what you heard today and you want to hear more, please click on the subscribe button.